AI and the state, when governments meet general intelligence. Dario Amodei published something last week that you should actually read, not just skim the headlines about. In his statement on Anthropic's negotiations with the Department of War, the picture that emerges is sharper than the usual AI company does ethics press release. Anthropic signed a Pentagon contract last summer. January rolls around and the renegotiation demands arrive. Unrestricted access to all models for all lawful purposes. Anthropic asked for two guarantees: no mass surveillance of American citizens, and no fully autonomous weapons without human oversight. The W said no. Defense Secretary Hegseth reportedly gave them a deadline. Then came the supply chain risk threat, the same designation previously reserved for Huawei and ZTE. What makes this different from the usual safety theater is the specificity. Amodei didn't wave vaguely at responsible AI. He drew two concrete red lines and held them when the most powerful customer on Earth pushed back. Whether you think those lines are in the right place is a separate question. The point is that lines existed at all. We've been covering this standoff for 3 consecutive editions now, and each iteration reveals more about the structural forces at play. A government that views AI capability as a national security asset that it cannot afford to let private companies gatekeep, and a lab that knows its entire brand depends on not becoming the thing it warns about. Daniel Miessler's The Great Transition essay provides the macro lens this story needs. His thesis: we're not in a technology upgrade cycle. We're in a civilizational phase transition. Knowledge goes public. Products become APIs. Consumers disappear because AI agents handle procurement. Security becomes AI via AI. The state either adapts or gets routed around. It's the kind of essay where you nod through the first half and then hit a paragraph that makes you set down your coffee. His prediction that ideal state management, where governments are essentially optimized by AI systems, is coming whether we plan for it or not, frames the Anthropic standoff perfectly. This isn't a procurement dispute. It's the opening negotiation of who controls the most powerful technology in human history. Agent security. The runtime supply chain nobody audits. And ArcSieve Paper 2602-19555 introduces a framework for thinking about agentic AI as a cybersecurity attack surface. The key contribution: a runtime supply chain taxonomy. When your AI agent calls a tool, loads a plugin, or reads from an MCP server, each of those interactions is a supply chain dependency. Except unlike NPM packages, there's no lock file, no hash verification, and no audit trail. The paper describes a viral agent loop where a compromised tool poisons the agent's context, which then propagates the compromise to every subsequent tool call in the chain. Their proposed defense: a zero-trust runtime architecture with cryptographic attestation at every boundary. Reads like what we should have built before shipping agents to production. We didn't, of course. The A2SPA project arrives at the same conclusion from a different direction. Their argument: the modern AI agent stack has a missing layer. You've got orchestration lang chain, crew AI, and you've got execution tools, APIs, but between them sits nothing. No authentication, no payload signing, no nonce/replay protection. A2SPA proposes a cryptographic layer 5 inches that sits between orchestration and execution, signing every tool invocation and verifying every response. It's the kind of proposal that seems obvious in retrospect. We've had TLS for HTTP since 1995. But AI agents are calling tools over unsigned plaintext in 2026. On the offensive side, a map elite's approach to jailbreak mapping looks promising. Instead of testing individual jailbreak prompts one at a time, researchers used the quality diversity algorithm to systematically explore the full behavioral attack surface. The result: 63% behavioral coverage per model, revealing attraction basins, regions of prompt space where the model is structurally vulnerable regardless of specific phrasing. The practical implication is that you can generate a topological fingerprint of a model's vulnerability surface, which means red teaming becomes a science rather than an art. We've covered jailbreak research across dozens of editions. From adversarial poetry 60% success rates to gradient-based UJA attacks. But this was the first work I've seen that treats the problem cartographically. The agentic developer toolkit grows up. The agentic coding space is maturing from look, the AI wrote code, to here's how professionals actually structure AI-assisted development. A thoughtful piece on spec-driven development with Claude Code lays out 3 maturity levels. Spec first: write the spec. Hand it to the agent. Spec-anchored agent writes code, but refers back to a spec for alignment, and spec as source the spec itself is executable. The author pairs this with AWS Agent Core Gateway as the infrastructure layer, showing how specs flow from design through generation to deployment. It's the kind of methodology that turns the vibe coding meme into something you'd actually show your engineering manager. Our editorial memory shows this exact arc. From the early vibe coding versus specification debates of August 2025 to today's pragmatic middle ground where specs are living documents that agents consume and update. But methodology means nothing if you can't access your tools. A practical guide to running Claude Code from your phone. VPS plus Tmux plus Termius, with heartbeat scripts and session hooks to prevent disconnection. demonstrates that the IDE is now wherever you have a terminal. The author's setup survived a cross-country flight with spotty Wi-Fi. Steve Yeage's Gastown vision of orchestrating 20 to 30 Claude Code instances feels closer every week. The provenance question is getting increasingly urgent. Git Memento is a Git extension that attaches AI session traces as Git notes on commits. So when someone asks, why did the agent make this change? The full reasoning chain is right there in the commit metadata. It supports both Codex and Claude sessions, and the traces persist through rebases and cherry picks. As AI writes more of our code, the who decided why question becomes as important as the code itself. Our archive shows this concern surfacing repeatedly since late 2025. From IO's 12-character hex checkpoints to Git AI's line-level attribution to Fleet Code's per session work trees. Git Memento is the cleanest solution yet because it uses Git's native notes mechanism rather than inventing new infrastructure. Cursor's security demo transcript shows the other side of the coin, using AI agents offensively for security assessments. Travis walked through a live assessment of OpenClaw, demonstrating plan mode, sandbox practices, and bugbot integration. The most interesting moment, the agent identified a vulnerability the human hadn't noticed, then explained its reasoning chain in real time. And for the quality-obsessed, AQE's Portable Orchestra takes the notion of portable, shareable development intelligence further. It exports quality brains, reusable test strategies, min-cut optimization, cryptographic witness chains, as RVF bundles that can be imported into any of 11 supported platforms. Think of it as Git Memento for QA. The reasoning travels with the artifact. AI as architecture archaeologist. Open dev tools capture network traffic, feed it to an LLM. Opus works well here, and ask it to reconstruct the system architecture. No source code access needed. No documentation required. Just production traffic and a model that can reason about HTTP patterns. The implications cut both ways. This is extraordinary for learning system design, but it also means every public-facing application is now an open book to anyone with a browser and a subscription to an AI API. Competitive intelligence, security auditing, and architectural learning all just collapsed into the same workflow. Our editorial archive has strong coverage of AI-assisted code comprehension, from LogicStamp's AST parsing to hierarchical code summaries. But this archaeology approach, reconstructing design intent from runtime behavior, is a genuinely novel contribution that deserves its own methodology name. The Slack teardown captured over 200 API calls during a single boot sequence. What emerged? Gauntry V2 SPA framework, Flannel Edge Cache Slack's own CDN layer, Loom distributed message index, and the HHVM runtime still humming along underneath. The analysis revealed that Slack's real-time messaging actually involves a complex choreography of lazy-loaded channels, present subscriptions, and message history hydration. Far more sophisticated than WebSocket pushes messages to clients. The Netflix teardown was equally revealing. 177 requests captured, exposing the Akira SPA, the Cadmium video player, the ongoing Falcor to GraphQL migration, FTL quality probing, MSL encryption, and the OpenConnect CDN architecture. The most surprising finding was how much client-side logic Netflix uses for adaptive streaming. The player makes dozens of measurement calls before selecting a bitrate, and the MSL encryption layer operates independently of TLS. Open source, tools for the paranoid and the curious. Scripling is one of those projects where the README alone tells you the author has been in the trenches. It's an adaptive web scraping framework that handles anti-bot defenses automatically. Browser fingerprint rotation, CAPTCHA detection, request throttling, while running 784x faster than Beautiful Soup for parsing. It ships with its own MCP server, meaning your AI agent can scrape as a tool call. The editorial memory tracks an escalating arms race between scrapers and anti-bot defenses, from ethical debates in 2025 through Thermoptic's Cloudflare bypass to HTTP Cloak's TLS fingerprinting. Scrappling sits at the adaptive middle ground. It doesn't try to defeat specific defenses, it learns the defense patterns and adjusts. SimWorld drops a full UE5-based open-ended simulator for LLM and vision language agents. A NeurIPS 2025 Spotlight paper, it provides a gym-like API for agents to navigate, interact with objects, and accomplish goals in photorealistic 3D environments. The gap between agent passes benchmark and agent operates in the physical world has always been enormous. SimWorld narrows it by giving researchers a controlled but complex testing ground where failure doesn't break anything expensive. Revector OS takes the local-first philosophy to its logical conclusion, a semantic intelligence layer for macOS that indexes your entire file system using ONNX embeddings, HNSW search, and a knowledge graph. All in 252 MB of RAM with 0 network calls. You type that migration strategy doc, and it finds it in 12 ms. Through MCP, Claude can query your local knowledge graph directly. The progression from basic Alama demos to Rust-native semantic infrastructure is one of the clearest arcs in our editorial archive. World Monitor aggregates real-time OSINT feeds. Military aircraft tracking, GDELT news, conflict data from Uppsala, polymarket prediction markets, NASA firm's satellite thermal detection, and Israel Home Front Command rocket alerts into a single dashboard with composite scoring. It auto-refreshes every 5 minutes and translates articles from 100+ languages. It's the kind of tool that makes you realize how much structured intelligence is publicly available if someone bothers to aggregate it properly. On the research side, Wi-Fi dense pose explores through-wall human pose estimation using Wi-Fi signals, the kind of capability that simultaneously fascinates and terrifies. And the contrastive AI manifesto argues for a fundamentally different approach to intelligence, coherence through contrast rather than scale, using hyperbolic geometry to enforce that every mutation requires proof of improvement. Research frontiers, when small models learn and physics gets weird. A clean empirical result from the local LMA community. RLVR reinforcement learning with verifiable rewards on top of fine-tuned 1.7B parameter models helps generative tasks by plus 2.0 percentage points but hurts classification tasks by minus 0.7 pp. The explanation is elegant. GRPO, the RL algorithm, produces near zero gradients when supervised fine-tuning has already converged on structured outputs, meaning RL adds noise rather than signal. For generative tasks where there's genuine distributional exploration to do, RLVR still has room to improve. This gives production ML teams a decision rule. If your task has a fixed answer format, skip RL. If it requires open-ended generation, RL post SFT still wins. Our archive has tracked RLVR across a dozen episodes, from the Rubicon framework to autonomous fine-tuning. But this is the clearest when to use it guidance we've seen. Further afield, a research synthesis on Weber electrodynamics and thermodynamic memory connects 6 literature streams: the Weber bracket, dusty plasma neural network discoveries, and toroidal geometry, into a speculative but provocative framework for information storage in physical systems. The core idea that certain electromagnetic configurations naturally encode and retrieve information through thermodynamic processes, which would mean computation isn't just something we impose on matter. It's something matter already does, given the right geometry. This is the kind of paper that either goes nowhere or changes everything in 15 years. Zero prior coverage in our archive, which alone makes it worth flagging. MinusPod solves a problem millions of podcast listeners share. It uses Whisper for transcription and Claude or Allama locally to identify and remove ad segments from podcasts. Entirely local, entirely open source. The pipeline is straightforward. Transcribe, classify segments, reconstruct audio without the ads. And the result is exactly what you'd expect: your podcasts, minus the sponsor reads. And finally, Mitapipe, a tiny Linux utility that bridges the ALSE sequencer to plain text on stdin/stdout. Write echo kit 1 note on 6.0.127 vertical bar Mitapipe and you've sent a MIDI note. Read from its output and you've got a real-time MIDI monitor. It uses the ALSA sequencer API, not raw MIDI, which means multiple clients can share a device simultaneously, and it plays nicely with pipewire setups. It's the Unix philosophy applied to music hardware. Everything is a text stream. And it means any shell script, any language, any LLM can now speak MIDI fluently. Pair it with a coproc in Bash and you've got bidirectional MIDI in a shell script. Licensed under the EU PIL, built in 2026, and solving a problem that's existed since 1983.